If we come to the execution integrity of any model, let's say I am a developer and something goes terribly wrong in the production of things, what would I be able to look at later? Like, let's say if I was able to check and compare, what would the audit trail actually give me?
That's a good question. You used to be able to get more. You used to be able to get what are called logits or probability traces out of the GPT models. There was some more extensive logging that was provided, but if you're to look these days, actually you get almost nothing. So
Exactly.
from a major provider, you get a log that a query happened. You get a number of tokens that you provided that went in, and you get a number of tokens that they say went out. And crucially, you don't actually get all the output tokens, because what these models do is they think to themselves, they reason, they produce a lot of tokens that way, but those tokens aren't shared with the user. So actually, you're fully trusting the provider when they say, yes, we consumed 300,000 tokens in order to produce this response. So it's kind of hard to explain the negative, but the first thing that you're missing is any reasonable accounting of how much thinking the model actually did. You
Right.
only know that at the very highest level, and you only know that in terms that the model provider allows you to see. The next thing that you're missing is any sort of execution trace for the model itself. GPT, for example, has what's called auto routing, where it will determine which of a selection of models it's going to run in response to a query. It will also determine how much reasoning to apply based on the complexity that it perceives is in your query. And
Right.
actually get no logs about which models were chosen and how much reasoning was actually applied to our query. So that's another thing that we're missing. Another thing that we're missing is we are not told what compression was applied to the model that actually ran. So for those who may be unfamiliar, models take up a lot of memory in GPUs, and GPU memory is incredibly expensive. In fact, GPUs have eaten up so much of the world's memory demand recently because of the demand for machine intelligence that regular consumer memory prices are expanding. And so there's an economic pressure for model providers to compress these models down, which reduces their intelligence, but also reduces the memory demands they make on hardware. And they are not transparent about when they do that. And the result is that that's another thing that we
Right.
don't get any information about. Then there's another thing that we don't get any information about, which is whether or not the exact prompt that we put in was actually the prompt that was run on the model. Now, a trivial example of this is if you're using ChatGPT's image model, you may notice that you can put in a very simple prompt, like draw a picture of a monkey eating a banana, and you will get a vastly detailed result. And you may wonder, how is that happening? The way that it's happening is through a technique called prompt rewriting, and prompt expansion, where behind the scenes, they're taking that simple prompt and they are breaking it down into many different components and subdescriptions of a scene, which are then rendered as an image. That's a trivial example, but other examples could be more serious. For example, you may have a question about the stock market, about
Okay.
something that's happening with, let's say, Apple stock. And the model behind the scenes may rewrite your query and say, well, Don't give the user in your response anything that could be construed as financial advice. In other words, it may change its instructions to itself in a way that go against your interests with no transparency back to you. And so if you kind of follow that chain through, what that means is you're paying for an entirely opaque service that may actually go against your financial or economic interests because those are clashing with those of the provider, and you will get no insight into how those collisions were resolved. Maybe they resolve in your favor, maybe they don't. So that's a huge gap. Like, you don't know how your prompt was rewritten. You don't know what safety guardrails were applied to your prompt. You don't know what additional instructions the model provider injected into the execution of that prompt. So that's one thing. But then another thing that's missing is actually you don't know what context was provided alongside that prompt. So you may upload a document. You may upload a PDF document. You want the artificial intelligence to read the entire document, consider it carefully as it formulates its response. But that's expensive. Taking a whole document, ingesting it is really expensive. And so what the provider may do behind the scenes is cheat a little bit, summarize your document, reduce the complexity of it, or just use snippets of your document as the input instead of the whole document. And that's really good for them. That saves them a lot of money on memory, what we call the key value cache. But it kind of deprives you of a complete response that could be better than the response that you got. So I could go on and on. There are all sorts of things that are omitted and changed, but at a very high level, you only know that something that vaguely resembled the query that you were posing was actually executed. And you have no idea about the implementation details of that, which I just want to emphasize is a really unique situation in the history of IT infrastructure.
Right.
If you look at something like Amazon, they bill you by the second for Lambda, which is a serverless product. You can consume database services from them and know exactly what tables were queried, how long it took to execute those queries. You're billed for that. For many software as a service products, the same thing is true. Like, if something is affecting your cost basis, then you know about it. But somehow, the artificial intelligence companies have convinced people that this is not important and information that doesn't need to be shared.
I think there's soon going to be like a tragedy of the commons, I would say, where everyone is going to have like spamming cheap inference, and then the quality of service is going to collapse terribly. Because, see, I just think in my worldview, centralized AI has only two options. They can either go with availability, they can always give us answers, or they can go with quality. But like you said, with their entire GPUs melting and them having rate limits, they are obviously going to go with availability. Then there will soon be, like I said, a tragedy of the commons. So, anyway, we talked about, I would say, the first layer, Travis, which is even if the run is provable, the answer can still be wrong, right? Because of the hallucinations, or be the bad grounding, or even the retrieval in the RAG, or even people misusing these tools, right? So, what do you think should be like a second layer? Or what are the truth checks that you would expect from someone who is serious about building something on top of verified inference?
That's a good question. I want to underscore that verified inference is beyond what anyone in the industry does today from an IT standpoint. So that is a fundamental step forward, and I think a necessary one. Otherwise, you end up in the position that you're talking about, where it's a race to the bottom with
Correct.
opaque infrastructure providers who have misaligned incentives. So that's a huge step of verified inference. But then you can't stop there, obviously. And I think that there are a number of components that you can build on top that are helpful. And of course, as always, it depends on what your goals are.